for now, this is a mock-up.
Okay,
because we've had these custom made to kind of get the flank.
Won't be that long either, will it?
No, we want them long because in case we have to flap them over the parapet or under a condition and we need to get a good access, it's better to have a little bit more. And then we can just pick it up here. Right? And this has only been, I would say,
5 minutes.
Yeah, 5 minutes. And at this point, at which point is it okay to put it in the oven, would you say? Like how long should we let this bond before we start thermoforming it?
So for the thermoform process, me personally, just to be on the safe side, I would wait 24 hours.
Right.
Because 24 hours, you have 90% of the strength of the tape.
Okay.
It's just 72 gives you that last 10%.
Got it. So it's
because
immediately, pretty much 5 minutes, you get 50%.
In 20 minutes, you get 50%.
So I'll go recap. In 20 minutes, you get 50% of the strength. 24 hours, 90%, and then in 72,
full cure is what we call it. And it's not really curing. What it is, on a microscopic level, if you look on a microscope, the VHP actually flows like a liquid. It's getting into all the nooks and crannies of your substrate.
Right.
Yeah.
So it's a bond.
Yeah.
And that's the thing. And it's a bond versus, let's say, this is not like basic tape.
It's not.
It's a bond.
It's not a chemical cure. It's just flowing out and
it's flowing into that surface area. It's a bizarre, counterintuitive thing, but I've worked with it and I've tried to tug these things off. And if you got behind this and you tried to tug it off, you're not going to move it. It doesn't matter how strong you are.
So I'm gonna just explain to you the secret sauce of VHP.
Example of
standard general purpose foam tape. Foam in the middle, adhesive on top, adhesive on bottom.
And that when this type of pressure is called, what type of pressure?
Cohesive strength.
Cohesive.
You just rip right through it.
Now we're going to go ahead and get to the 3M, the VHB bonding tape. And as I'm tugging, you see it's not wanting to come apart, but also it's stretching. And now as I let go,
it goes back.
And what is that part called?
That we call that viscoelasticity. The tape flows. And if I pull it real hard, after a while, I'm going to need less stress to hold it there, because the tape is absorbing that energy. And then
explain that part. You're getting into some interesting science there, because you got some big arms, and I know you probably don't have to go to the gym because you just pull on the tape.
So this is 1 square inch of tape.
Right.
So it takes about 60 psi to rip this. You can't rip it by cleaving it. Like you just keep bending over and cleaving it, But the tape expands, it goes back. The viscoelasticity tape. So as things heat up and expand and contract, so the metal and the plastic is going to expand and contract at different rates because they're different substrates. So the tape is going to flow with it.
And I want to talk about that because that's when you get into exterior large applications, you have to take into consideration expansion and contraction. And all materials expand and contract, and they expand and contract differently. So the galvanized metal would expand in its own behavior, have its own behavior, and the Corian panel would also have it. So now if they're expanding and contracting at different times, right, they're going to be going in different directions. And that's what this tape solves, which a mechanical connection doesn't really solve. And that's the difference. If you notice some of the best, the newest planes that are made, they're not using mechanical connections, rivets, they're actually gluing them together, bonding the metal pieces with glue.
And when you go to adhesives and tape technology, one rivet, that's where all the stress point is. The adhesive or tape spreads out that load, and that's exactly what VHP does.
Right. Yep. And that's how it's even stronger. And you can watch some of the videos. So in terms of longevity, can you say 100 years, 200 years? At a certain point, we don't know.
Yeah, so we've done aging and weathering testing, going out, 10,000 hours. And generally that's kind of our cutoff. If it stands for 10,000 hours, we just say it's going to last many, many, many years.
Right.
So I gave you the example of the O'Hare Airport, those mirror panels, since 1987.
Right.
That hotel in Dubai, the Burj, I forgot the name, the one that looks like a sail.
Yes.
Yeah. All those panels and glass, VHP.
Right.
That's a high wind environment, high heat environment.
And that's what I want people to understand, is that you have to understand, this is glass, giant panes of glass, 100 stories up, in extreme weather conditions, that is taped to the building. More or less, it's just taped to the side of the building.
It's taped to the frame.
Right? It's taped to the frame.
And then architectural panels, whether it's an ACM panel, like the Disney Concert Hall, or now more and more panels are becoming plate panels, 100% aluminum panels. Same thing, our tape is used to bond that and bond the stiffness on that as well.
Well, I'm a big fan of the tape, an early adopter. I've used
Perfect.
it in other applications. I've used it on facades.
Okay.
I've shown people the tape who've laughed at it and laughed at me. And
So-
then I've seen them actually steal some of my tape and go ahead and use it and go, wait a minute, where can I get some more of that stuff?